therefore the marine. The Scotch, I'm not quite sure, but I think it has to do with their thriftiness. Or, you know, and you could take that, you might say they're tight asses. Okay, so what? But they've applied this name, so it's kind of hung to it. Scotch Marine is hung there, and I'm not real sure why, but it is what it is. A firebox boiler is a fire tube boiler that uses an arch-shaped furnace. This uses an arch shape in here instead of just a tube going down through it. You have a lot of water through here. Going back to the other things about boilers themselves and characteristics of them, water tube boilers have flame around the tubes. So the heat only has to travel a maximum of 1 to 2 inches from the outside edge of where the heat is enveloping this tube to get to the innermost section of water that it's trying to heat. When you go to this style of a boiler, you've got a massive amount of water around it so that you could have several inches between where the tube surface is and the actual surface of the water in the middle of it. Works fine, but it's slow in its recovery. So you don't want this to do process, but the beauty of it is once you build one like this and you put it in like a high-rise or an apartment complex or any normal building, it maintains the heat relatively well for a long period of time. It's stable. Whether it's hot water or steam, it stays relatively stable. This is the push nipple cast iron sectional boiler. Well, all that is again, remember if you've ever seen, and everybody has at some time or other, cast iron radiators. This is just nothing more than cast iron radiators, very large, but put together. And there's a couple of ways of putting them together. What they're describing here is each section, and the beauty of this is if you have a section that's damaged, you can pull the boiler apart, generally speaking, and put a new section in. Or if you have a place where you can't, it's very small doorways, and you can't get a large complete boiler in, but you can get a section in. You can bring that section in, and then it's field assembled. There are 2 ways of field assembling them. The original way is this way with the push nipple. Now what you've got is a hole on each radiator up here of the right size and diameter already cast in there. The nipple itself that goes in there is tapered. So it's a slug type of fit. It's tapered. It's not threaded, it's just tapered. So you have a piece of metal with a shoulder on it, tapered on both ends. When you put these two together, it pulls that tapered end into a tapered female slot in the cast iron section, and that's how it's assembled. And you put it together with tie rods, you pull it together. The more current way that they do it is because now we've come up with all kinds of new forms of rubber and materials to use, they use an O-ring. So it becomes much easier. This way is not bad, but it's time consuming, and it's difficult to get them all aligned and make sure everything goes together exactly perfect. What you have on the newer style with the O-rings that are in there, big flat O-rings that go in there, is a male-female, and the O-ring fits right inside, and it just compactly fits together. You still have to pull it together with stay bolts, but it's not nearly as time-consuming or as probable to unpredictable problems, I guess, is when you're assembling it. If you don't get the nipples right, you don't get them lubricated right, you don't get it all pulled together right, you're either going to have a leak or you're going to crack a section. So you have to be very careful putting them together. Scale on any boiler insulates the surface. What we're looking for here in any of these installations is we want the maximum amount of heat that we are paying for to be transferred into the medium. And so scale actually winds up being an insulator, and you're putting a lot of heat in there and not getting much for it. So your bang for your buck goes way down. You're not getting much for what you're putting out. In addition, the addition of water. When you have a boiler that's hot and you were to go over and just, oh my God, the low water cutoff is not working and it's continued to heat, and now we're really low on water, so let's throw some water to it. Well, when you throw cold water against a hot metal surface, shit happens. And it's never nice. It's never good. It doesn't happen this extremely all the time, but it does occur. You'll crack, blow, do something with it. Never put cold water in a hot boiler. Never. Ever. If you have to, shut the boiler down, let it cool down, let its surface cool down, and very slowly put water in. Water in the boiler is generally returned, whether, in this case we'll say it's a steam boiler. Water in the boiler is returned typically as a fairly warm condensate. The difference between 210 10 degree water and 212 degree steam is only 2 degrees, but one's water and one's steam. So if we put the warmer water back in, it tends to eliminate problems. If you have a high pressure steam system, almost always high pressure steam, because it's running at a higher pressure, also means that its boiling point is increased. As its boiling point is increased, i.e. the temperature is increased. The water on a 15-pound boiler, 240 degrees. If you've got a 150-pound boiler, the water going into it needs to be closer. You can only get it so hot, but you need to have it almost ready to boil when it goes back in there, because the water temperature that's sitting in the boiler is going to be somewhere in the 300, 320 degree range, because it's under pressure. Increased pressure, increased temperature, directly proportional to one another. So you have what's called a deaerator that takes oxygen out of it, and it also heats the water, typically with a device called a sparging valve, where you actively inject live steam into the condensate to make the water almost boil. You want it very, very close to boiling temperature. Tube leaks. You've all seen these probably if you've got a fire tube boiler. Right around the face of them, you'll see them dripping down. It's why we open them up every year and look at them. Tube leaks. Why would you have tube leaks? Could be a number of reasons. Age of the boiler. Most common thing that happens with tube leaks is the way the boiler is being operated. Two things happen. One, if your pH isn't right in your water treatment, and I can't stress enough, you've got to keep the water treatment up. Untreated water is the death of a boiler. We put boilers in for people, and literally inside of a year, 2 at the most, we're replacing them. If you do not maintain the water quality, you can't expect the boiler to do anything except what it does. And that's going to, first of all, calcify everything on the inside. It's going to cook it out. And then the second thing it's going to do is start leaking. And if you're lucky, you can replace and repair. If you're not, it cracks, you're done, you get a new one. You have to maintain these. And the boiler water solids that come out of there typically are due to a leak that's around the tube. Tubes are rolled in around the surface there. That's all that keeps them in there. Heat expands against these surfaces and seals them. It's not uncommon when you first start a boiler, and I know if I ask for a raise of hands, there'd probably be 50% or more of you. When you go to start a boiler up like we have this last couple of weeks or month, when the weather started getting cold, do you notice that there's a whole hell of a lot of condensate on the floor all of a sudden? There's water, seems like everywhere, and you wonder, are my tubes leaking? They possibly could be leaking, but the most active reason, the most probable reason for that is the boiler is sweating on the inside. And why it's sweating is because we're putting this extremely hot temperature gas, this heat from the combustion is going in and it's meeting this very cold metal. And as it meets this very cold metal with this cold water, even 100 degree water is cool compared to a 1600 degree temperature flame. So what it does is it precipitates out any of the humidity that's in the air. It basically boils the moisture in the air out. And so what happens is that moisture then condenses because it's a cooler surface. It's hard to put your head around it, but you're actually condensing moisture out of the air just like you would in a dehumidifier. But you're condensing it in these tubes. When you condense that, you're going to, as I mentioned before, one of the problems is if you don't keep that temperature up, and there's no way to do this except keep the boiler on very low flame, as low as you can during the warm-up period. All of them do it. But once it's done, you don't want to see that continue. You don't want to see it perpetuate, because this is the kind of crap that happens. You wind up with solids in the airstream that are precipitated out, and then they start grabbing a hold, rusting, scaling, and breaking. So you want to keep that temperature up. Once that water is dissipated, it basically boils it off, evaporates it, and you're done. So sometimes it could happen for 5 minutes, 10 minutes, 30 minutes, an hour maybe. But once it's done, and you shouldn't have any more of that. If you do, then you probably do have a leak. That could be thermal expansion. There are a number of ways that you can control pressures and a number of ways to control burners. You can have a simple one that comes on when it calls, goes off. A lot of houses in the Northeast up here used to have the old cast iron boilers and things in there, and there's still a bunch of them around. Basically, they've got a thermostat upstairs, thermostat calls, boiler comes on, heats, steam comes up, water comes up, whatever it is, heats the space, goes off, on-off. Simple on-off control. Then you've got another one where you've got the next step up where you've got an on, then you start on in a low flame, and then it goes to a high flame automatically. and it stays there until it's time for it to shut off, and it goes off. So that's a low, high, on, off. Very simple. It comes on low, goes to high, stays there, shuts off, starts the cycle again. In doing this, you've got modulation, which is the best way, and there you modulate the flame. You take the flame and you make it any direction, any size you want to meet the demand that's in the system. Steam traps. Again, we've got to just touch all these things. I could spend hours on any one of these subjects, but steam traps. There are a lot of steam traps out there and a lot of different kinds. If you have a steam system, and I know some of you guys at MC still have some around, I mean they're around all over the place, maintaining those steam traps is extremely important. One steam trap passing through a pound of steam an hour can lose you a tremendous amount of heat, and it can cost you a lot in fuel usage. Low water conditions, same thing as dumping hot water, or cold water, I'm sorry, into a boiler. Low water conditions, it's not good. You should have your safeties checked every year. If you don't do it, have us do it, have somebody do it, but check your safeties. Your low water safety is critical to the operation. Barometric dampers. I show this only as an example. Sometimes guys don't know what they're looking at. A barometric damper is oftentimes on the exhaust or the flue, the chimney going up. Its purpose is to relieve some of the pressure and allow the pressure from a room to go up the chimney without going through the boiler. We want to maintain a specific volume of air-fuel mixture in that boiler. And so we use these barometric dampers to introduce, if there's a big draft, we have to maintain that draft to keep it going, but we don't want to maintain it through the boiler. It sucks heat out of the boiler and your stack temperature goes up. Automatic flame sensors. There are a number of kinds, types. The ones you most often see, and for lack of a better term, I'm going to use the term FireEye, but FireEye is a manufacturer. Honeywell also is the other manufacturer that makes them. So it could be either one. But you have a scanner typically nowadays that looks at it. That scanner is looking at an ultraviolet light that is produced in there. Years ago, they used to have an infrared scanner. You can still find them, but infrared is not as predictable or as manageable as ultraviolet. When you have something that's infrared, the scanner can see a hot metal spot and interpret that as a flame. Whereas with an ultraviolet, you either have it or you don't. And the only way you'll have it is if there's an actual flame going on. Ultraviolet will not exist in there other than that. Flue gas analyzers, I don't know how many of you guys have them or use them. We have them, we use them all the time. It's almost imperative. It's the only way to maintain any kind of control over your boiler and how it's running. You have to check them. And typically, you need to check them at least once a year, sometimes twice. Why twice? Because in the early part of the season, like right now, the gas that's being delivered is at one quality and one pressure. The temperature outside is at one temperature and pressure. As the winter gets further on, all of these variables change. The closer you maintain that boiler to the existing conditions, the more efficient it is. Real quickly, we're going to go through fuel, oxygen, and heat. That's what's required. It's very simple. One of the things I would caution everyone in this room, we all work around high voltage, high amperage electrical systems. We can't see them, and therefore we kind of put them in the back of our mind, and we've all heard the horror stories of people being hurt with them. This device, this boiler, any device, I don't care if it's a furnace, but a boiler in particular, is nothing more than a controlled, and I use that word in parentheses, it is a controlled explosion, period. It is singularly more responsible probably for more accidents than electricity is in a given year in our industry. We tend not to put much into it because we're used to seeing a flame. We're used to being around that, whether it's at home in the barbecue grill, whether it's the furnace downstairs, whatever it is. But for some reason, we tend to be lax in our approach to these devices. And I can't caution you enough. This is dangerous shit. Make sure you know what you're doing before you do it. If you don't seek help, always, always, always ask the question, am I ready to go right now? Because if I'm not, I'm going to double check everything I just checked again. I double and triple check everything. What I was talking about earlier, we're going to go into that just a little bit more.